So we are doing cones today. Cones are very similar to cylinders. Cones, the difference, have only one base. Now that base is still a circle, and this is the lateral part that we're going to solve for the lateral area. So, on that base, we have the point here being your center, and from the center to a point on the circle, that is called your radius. That'll be the R in your formula. And then we have from this point up at the top the vertex point. If I go from the vertex straight down perpendicular to the center, that tells us how tall is that cone. So that is your height, which is your h. Now with a cone though, it can be really tall, it can be short, but this slant right here, it can be a really wide cone or it can be a really skinny cone. So we have to be able to find a way to determine what kind of slant is that at. And so that we call is the slant height. And that's this length right here is the slant height. And then for whatever reason, they determined the letter for slant height is L. So we have three variables that we're going to be solving for. We have our radius, we have our height, and we have our slant height. Now, in this shape, we're going to cue in on this sliver of a triangle. And so, how do we solve for right triangles? We've had a couple of different ways. We've used Pythagorean theorem, which is a squared plus b squared equals c squared. We've learned Pythagorean triples. A lot of your homework has Pythagorean triples. We can even use 45 rules, 45, 45, 90, which is x, and x square root of 2. And then the last type is our 30, 60, 90 special right triangles with x, x root 3, and 2x. So any and all of those we can use to find this sliver of a triangle on the inside to find your radius, your height, or your slant height. So our lateral area formula before was the cylinder 2 pi r h. But now, instead of having a rectangle that's going around, we have a triangle at the top. And so that ends up creating basically half of a rectangle. So if I were to take half of 2 is 1. So now I have 1 pi times the radius, and then the height before, the distance between the two bases. Well, now I'm going from the vertex to the base, So I'm actually going to substitute out that height for the slant height because you're going from the top to the base. Then we have our surface area formula. Before that, surface area formula was LA plus 2B. And so our surface area, the lateral area, I can use that pi RL. Now before that, cylinder had 2 bases, but now we only have, we said, 1 base. So instead of 2 pi r squared, I'm only going to add 1 of those circles, 1 of the pi r squared. And then volume before was the area of the base and times it by the height. But kind of like we realized over here with a cone, it doesn't have that extra base up there. So it's not the full volume anymore. And I've got a short little clip to kind of show you what ends up happening with the volume. So that's this.
In this video, we'll demonstrate the ratio of a volume of a cone and a volume of a cylinder. We have a cone and a cylinder with the same diameter and height. The cylinder is filled exactly with 3 full cones of water. The volume of the cone is 1/3 of the volume of the cylinder.
Ooh, ah, yay! So we discovered the volume formula is now 1/3 of the original volume pi r squared h. So once we have all of our radius, height, and slant height, the rest is just plugging in. And then, like before, our units for lateral area and surface area are squared, but volume is cubed. So on here, this first one, I'm going to cue in on my sliver of a triangle. They also gave me a hint that this angle right here is 30. It's kind of faint, but it is a 30. So that tells us we end up with a 30, 60, 90 special right triangle. And so opposite of 30 is x, opposite of 60 is x square root of 3, and the hypotenuse is 2x. So I circle my given information, and I end up finding out that x is 3. And that should make sense right here because 2 times 3 is 6, so that does follow that rule. Now this one right here, this x, that's 3, is representing our radius. So I'm going to write that down that our radius is 3. This piece here, that is the slant, and so our slant height is 6, and then the internal height, how tall is it, straight down perpendicular, that is our x square root of 3. And we found out that x was 3, so our height is 3 square root of 3. And now we have everything that we need for LASAV. Lateral area is pi RL. Radius is 3. our slant height is 6, and 3 times 6 is 18. And go back and make sure it's written up here. We are going to leave in terms of pi. Kind of same thing we've been doing. So final answer is 18 pi with our units. Our units are meters, so meters squared. Then we have the surface area. Surface area is LA plus, remember, 1 base. Our lateral area I can plug in, and plus pi radius being 3, and we square it. So simplifying this down a little bit, 3 squared is 9. And so then I look on here, do they both have pi? They do. Neither one of them has a square root, so I can actually add them together to make 27 pi with meters squared. And then we have volume. Volume we found out is 1/3 pi r squared h. The radius is 3. And my height is 3 square root of 3. So simplifying some of this down, we are doing all of the numbers. So 1/3 of 3 squared. 3 squared is 9. 1/3 of 9 is 3. But I also have this 3 here, so we end up with 9 square root of 3 pi. They're all being multiplied together, so they just combine together to make 9 square root of 3 pi with meters cubed. Then on the next side, we've got our sliver of a triangle. That is our starting point here. And I do notice that it has a square root of 2. And when we have a square root of 2, it could potentially be a 45, 45, 90. Well, with that rule, remember, let's say if it was 10, 10, that would be 10 square root of 2. Well, this is 5 and blank and 5 square root of 2. So it does follow our 45 rule. So we have a 45, 45, 90 with the rule x, x, and x square root of 2. My given information is that x is 5, and that does follow that rule right there. So my given being 5, I can plug in here, which is my radius. So I'll write down my radius is 5. My slant height. My slant height is 5 square root of 2. That was given. And then my internal height, that was my x that helped us find the radius. That was 5. So now we LASAV. Lateral area is pi RL. Radius is 5. Slant height is 5 square root of 2. I can multiply those numbers together. 5 times 5 is 25. I do have a square root of 2, and I have the pi. And these are units squared. My surface area, LA plus 1B. Lateral area, I plug in, plus pi radius is 5, and we square it. Just continuing copying down as I go to simplify. Now 5 squared is 25. Do they both have pi? Yes. But this one has a square root and this one does not. So remember, when they are like that, they are not like terms. So I will leave this as 25 square root of 2 pi plus the 25 pi, and units are squared. And then we've got our volume formula. Radius is 5, and my height is 5. And I just multiply all the numbers together. Now 5 squared is 25. 25 times 5 is 125. But if I try to divide 125 by 3, it's a decimal. So we leave this as a fraction. So you will leave it as 125 over 3 pi. And you should have a couple of problems on your assignment that do end up as a fraction. Last one, we are working backwards. And the biggest mistake that y'all are making with these is you're starting off with the wrong formula. Also, this particular problem is missing a picture. So we're going to draw our picture really quick. So if it gives us volume, that means I need to write down my volume formula. 1/3. And I forgot my pi in here. Pi. Oh my gosh, let's just rewrite it. Volume 1/3 pi r squared h. So if volume is, I am substituting that out for my V, for the volume. Now they also gave us that the radius is 3 feet. And I need to find that internal height. So simplifying this down some, and that should be 3 squared, yes? So make sure to add that because I missed it. 1/3 of 3 squared. 3 squared is 9. So 1/3 of 9 is 3. Now everything that's attached to my H, I have a 3 that's attached I need to get rid of, but I also have the pi, and pi divided by itself simplifies to 1. So we end up finding out my height is 4. You sometimes, y'all get in a rush and you end up writing 4 pi as your height. It is not 4 pi, it is just 4 because we divided out that pi. And they also need us to find the slant height, so we're looking at our sliver of a triangle. They don't give us a 30 degrees or a 60. They do not follow the rule of x root 2. So what we need to do is Pythagorean theorem. And even if you're not sure if it's a 45 or a 30-60 or this, Pythagorean theorem should always be the go-to. So this one's also a triple. It is a 3, 4, 5 triple. So my slant height is 5 feet. The last thing, we'll plug in quickly the lateral area, pi RL. Radius is 3. Slant height, we just found out with Pythagorean theorem, is 5. 5 times 3 is 15, leaving terms of pi, feet squared. And surface area is LA plus 1 base. Plugging these things in. Radius is 3. 3 squared is 9. And do they both have pi? They do. And does either one have a square root? No, they don't. So I can actually add them together for a sum of 24 pi feet squared. So the rest of the time y'all are working on your assignment.